We will be dealing with functions in the McGraw-Hill Module 5. We are on 252 is where we're going to start. We have to remember how to name ordered pairs. Remember, we always start with the origin and how far to the left or right we go, and then how much we go up. So, right here, it wants us to use the graph from the quick review, and we're going to do point A. So how far to the right did we go? We went over 3. How far up did we go? We went up 5. So that is the coordinate for A. Then for evaluating expressions, this was what x is. So all I'm going to do is plug in for x and get my solution. So here I'm going to plug in for x. 3 times 4 minus 2, so that's 12 minus 2, which will get me 10. Okay. So, the mathematical relation. I'm going to change this color. There we go. Mathematical relation exists when two mathematical values are related in some way. A relation is a set of ordered pairs. So ordered pairs, and there's going to be a group of them. It's called a set. The input is going to be the x coordinate. The output is going to be the y coordinate. And relationships can be shown in any of these ways. It can be our relations. So it could either be ordered pairs, it could be tables, mapping you might not have seen before, and graphs. It could be shown in any of these ways. So a function is a specific type of relation. There's exactly one output to each input. What does that mean? The x value can only go to one y value. So if I look at this, 2 only goes to one output. 4 only goes to one output. 5 only goes to one output. 9 only goes to one output. Over here, 2 goes to 2 different things. The fact that it does that, that means it is not a function. The minute that a number that is one of the input values or the x values and it goes to 2 different outputs, it would not be a function. If I wrote this as an ordered pair, see how that 2 is repeated? It's going to 2 different places. Okay. This function, this is a function because the value is paired with exactly one output. This is not a function because 2 in the input is paired with 2 outputs, 1 and 3. Okay, so we're going to look at this down here. A mapping diagram can be used to determine whether a relationship is a function. Okay, so if we look at this, again, goes to 1, goes to 1. This, on the other hand, goes to 2 different things. The mapping diagram, not a function, shows the input, the input value of 1 is mapped to 3 and 5. Because an input value is mapped to more than one output, the relation is, is not a function. Okay, so let's look at this. 1 goes to 2 different things. So is that a function or not a function? This is not a function This is not a function. 1 is mapped to 2 different outputs. 1 and -1. Oh, sorry about that. I guess I could have just filled in the blank down below. Okay, let's look at this one. 2 goes straight here. 4 goes to 2 different things. So again, this is not a function. Because 4 is mapped to 2 different outputs. Oops, I didn't want to put that. I want to put -5 and -7. Okay, this next one, it says tables can be used to represent relations and functions. To determine whether the relationship shown in the table is a function, consider how the members of the input correspond to the members of the output. Okay, so if I look at this, none of those are repeated. This is a function because each member of the input, that means this right here, corresponds to exactly one member. This only goes to one number, only one number, only one number, only one number. Okay, so this one is not a function. Look at this. This repeats. That means it's going to 2 different things. So this is not a function because the members of the input, the ones, correspond to more than one member of the output. Specifically, 1 corresponds to both 2 and 4, and then also down here, 3 goes to both of these. So goes to both 6 and 8. Determine whether the relation is a function or not. Okay? Does -2 repeat itself? No. Goes to one thing. Goes to one thing. Goes to one thing. Goes to one thing. Yes, the output repeats itself, but we don't care about that part. We care about the fact of the input. Does the input repeat itself? Study the table. Are there any input values that correspond to more than one output? No, there's not. The relation is a function because each input value corresponds to exactly one output. So this one, I have 1 to 3, 2 to 3, 3 to 3. This 2 also goes to 4 because these 2 numbers are exactly the same. So that means 2 is going to 2 different numbers. So this is not a function. Because the input 2 goes to 2 different outputs, 3 and 4. Okay, so let's look at this one. The ordered pair of a relation can be graphed in the coordinate plane. Determine whether the relation shown on the graph is a function. You can do the vertical line. Okay, remember vertical lines look like this. Okay, that's not a very good vertical line, but it's a vertical line. If for each value of x, a vertical line passes through no more than one point on the graph, then the graph represents a function. Okay, so that means if I was to draw a bunch of vertical lines, does it only go through that graph one time? That's what it means. Sometimes it's called the pencil test. And if you were to take your pencil and move it across, does it only hit the graph one time, meaning the line that's drawn on the coordinate plane? Now, If the line passes through more than one point on the graph, then it is not a function. Okay? The graph is a function because the vertical line test shows that it always intersects the graph at exactly one point. This means that the input corresponds to helps if I read the rest of what it says, exactly 1 point, one output. So if I was to draw the vertical line here, draw one, oh, it hits one time. Uh-oh, it's hitting a whole bunch of times. Okay, every time I draw that vertical line, it's hitting in 2 spots. The graph is not a function because the vertical line test shows that it intersects the graph at more than 1 point. This means that an input corresponds to more than one output. Okay? Is this a function? Well, if I draw vertical lines, does it ever hit that graph more than once? So this is a function because the vertical line test shows that it always intersects the graph in exactly 1 point. This means that each input corresponds to exactly 1 output. Okay. So again, we're going to do the vertical line test. So if I was to draw vertical lines, I know these are horrible vertical lines. Would I hit this anywhere in more than one spot? Yeah, right here and right here, I hit it in more than one spot. The relation is not a function because the input does correspond to more than one output. Okay, so let's decide on this one. Oh, that was really a bad vertical line. If I was to do these, I should be doing them as smaller ones. Yes, it is a function. It is a function. Because the vertical line test only goes through 1 point at a time. Okay. Determine whether the relation shown in the graph is a function. Use the vertical line test on the graph. Does the vertical line ever pass through more than 1 point? Now, the relation is a function because each input corresponds to exactly 1 output. If I was to draw this one, it hit in more than 1, so this is not a function. Oops, not a function because the vertical line passes through more than 1 point at a time. Okay, awesome. Go ahead and start your homework.